mostly going to be following Hacktricks, to be honest. We have everything in Hacktricks, so why not? There is a page here in Hacktricks where there are actually several pages. Can I do this bigger? Yes, I can. There are some pages here in Hacktricks in the serialization. You will find information about the serialization in several different languages. In Node, we talk about prototype pollution, and in this page you will find definitely more easy explanation about what is prototype pollution, these objects, why this working, how does this work, why this is working in JavaScript, but for example not in Java or Python. You will have better in-depth explanation here. And there is also a page about how to get from prototype pollution to RCE. This is actually something I saw in a CTF, and then I researched a couple of weeks on myself on the topic because it looks really nice. And this is what we are going to be seeing today. So first of all, what is prototype pollution? So I have an example in my other screen to explain this. So imagine that, well, we are in a Node dynamic execution environment. We have this function that is checking if a pass object, in this case called user, is admin or is not admin. If the attribute admin is true, or anything that is equals to true in JavaScript, we are going to have like, hey, you are admin. Actually, this is in Spanish. Eres admin, bienvenido. Hey, you're admin, welcome. Or you're not admin, get out of here. Just a simple function to check if it is admin. And we are going to use the vulnerability prototype pollution to bypass this function. So now imagine that we have a user. We have a user that is actually admin. User.admin is true. So if we check it, well, and we are a regular user called in this case Carlos, that is not admin. We are not going to set the .admin to true. Then we can check, hey, the admin user is admin. Yep, admin, you are admin, welcome. We can check if the Carlos user is admin. Carlos, you are not admin, get out of here. Cool, that makes sense. But what happens if we could override? So every time you create an object in JavaScript, it is going to be inheriting by default from the parent prototype object. This can be very, very easily accessed if you just create an empty dictionary. Amplia, yeah, that makes sense. So let's do this a little bit larger. Sorry about that, guys. I think like this is okay. So this is basically the function. Function is admin is checking if .admin is true or false. We have created a user.admin true, then Carlos user doesn't have this .admin. And we check that admin, you're admin, congratulations, Carlos, you're not admin, get out of here. So, as I was saying, we have every object in JavaScript is going to be inheriting from this parent prototype that all objects by default depends on, and this is the easiest way to create an object. So we can access this prototype by just doing something like this. We are going to access the proto attribute from this object. In this case, it looks like it's empty. So as I was saying, if I do something like user regular.admin, this object is also inheriting from this parent prototype. Actually, I could do the same proto. In this case, I will get the null prototype object. So it's inheriting from that. So imagine that for some reason you manage to overwrite any attribute of an object in JavaScript that is, in this case, our object, and set it to any value. In this case, we are going to set it to true. So we will be modifying the proto attribute from the object obj.admin, the attribute admin from the proto attribute, and setting it to true. We are going this like this. Now, if we check, let's check this. If we check the prototype of user regular, notice that it has changed. This is because this object proto and user regular proto are the same one. So they are inheriting from the same parent prototype. So it's funny because now, even if we haven't touched the user regular, just because the attribute admin wasn't specifically defined for this user regular object, if we check if this regular user is admin, it says that it is actually admin. So this user.admin is now true, even if we haven't set it directly in the user admin. Even if we haven't set it directly in the user regular, just abusing what could be a prototype pollution vulnerability. Let me check the chat. Zoom in, please. Yeah. So this is basically the base of this prototype pollution vulnerability. We are going to be able to modify an arbitrary attribute of an arbitrary object with an arbitrary value. It's like that. We can set attributes to modify other stuff. In this case, we can set an arbitrary attribute of an arbitrary object to move back until the parent prototype in order to set something in the parent prototype so other objects being executed inside the Node.js dynamic environment are going to be inheriting these new attributes we just set, and we are going to be modifying the behavior of the project just because of this. Again, something very important. If I do user regular dot admin equals false, even if the prototype have the admin attribute as true, user regular dot admin is going to be false. However, note that if I create a new one and do a dot admin, it's going to be true because the prototype dot admin is true. But if you specifically set it, the value is going, the set value is the one used, not the one pollute. So it's important to know that we can only change the behavior modifying the values of attributes that are undefined. If the value is defined, even if the value is null, that value is going to be used. We need to attack undefined values, undefined attributes of objects. Hope that makes sense. Anyway, if you have any question, I'm from time to time checking the chat. Sorry, that will be the introduction. Yeah, exactly. So someone asks if you pollute the prototype and someone generates an object and the prototype has some attributes with a default value, the new object is going to inherit that value. Yes, they are, as long as the value was undefined. Cool. So let's start with some vulnerable code. In Hacktricks, you can find this that I'm going to try to make a little bit bigger. Yeah, you can find this. Here you can find a common function vulnerable to prototype pollution. you will usually find something like this. You're going to find something like receives a user control dictionary object and merge it with some object inside the code. In this case, the object that belongs to the code is an empty object, and this is the object that a user can control. The user might be able to control all the object, only some specific JSON parameters inside the object, but the thing is that the user needs to be able to control full attributes inside a dictionary object. In this case, the user controls the full object. So what we are doing here is we are going to be going through all the keys in the object given by the user. In this case, this is source, and we are going to be getting all the values from all the keys and setting them into the object that was created inside the code. In this case, that's called target, and it was an empty object. So what this function is doing is, if I pass something like hello 123, and this is called user input, and then we have the the target value like this. We are going to be putting the key hello and the value 123 inside this value. Actually, we can just do that to understand better how is this vulnerability working. So if we merge target value with user input, this object is not defined. Cool. Sorry, I need to declare this first. So we now have this. What we managed to do is to put hello 123 inside the target value. This will be the vulnerable function to prototype pollution. Why is this vulnerable to prototype pollution? Because we can define arbitrary attributes of an object that is going to be copied directly into an existing object. So we could put a malicious object with an input such as, I don't know, let me create it here very fast. The user input could be something like proto, because we want to override the prototype. This is equals to hi 123. Is this going to work here? And you can see that we manage, if we now create a new b.hi and define it, no, this is not going to work. We cannot do this directly inside the node console. The thing is that we can override the prototype object, the prototype parent object, with any value that then other objects are going to be used. Like we saw before, but now we are an attacker and we can override it. It's not like we need a node console to attack this. Let's continue. So we now understand the vulnerability. We now have an example of a vulnerable code, but we want to get RCE. As you can see, we have only talked about how to override attribute undefined attributes inside our running Node.js environment. We haven't talked about how to get RCE. And actually, I mean, this sysadmin example can be very dangerous. Like you can pre-base due to this vulnerability, but you probably want to find something more interesting than a privilege in a web server. You probably want to execute code, arbitrary code. Unfortunately, you cannot do that directly with this vulnerability, but we can influence other libraries to get arbitrary code execution through this vulnerability. So there was a write-up some months, several months ago. I don't know if even, 2021, 2022, I don't know. Where this guy, you can find the write-up here in Hacktwix. What he was doing is, okay, let's try to get RC from a prototype pollution inside, I think it was a Jira instance, I'm not sure. And what he was doing is, okay, so I know that so I know that Jira at some point is using the child process library to do a fork and execute something. Is there any way I can trick Jira to execute a different stuff while running the child process fork function, even if I cannot control the parameters being passed to fork? Because to be honest, it will be very, very easy to say fork, execute who am I. It will execute who am I, everybody will be happy. But you have a prototype pollution, you don't have direct RC. So is there any attribute of the prototype I could modify to force the fork function to execute arbitrary stuff, even if it apparently is said you need to execute this? Actually, there is a way. So we are going to be debugging this later, but you can see in the code we will be able to see that there is an attribute called env that is undefined and can have environment variables that are going to be later used in the fork function. So, okay, we know that we can execute fork, and that we can have we can indicate via prototype pollution arbitrary environment variables. How can we get from this awkward situation to a real RCE? The way is that fork function is going to be executing a new process of Node.js. We are going to be execute something related to Node. And Node, by default, is going to be reading the environmental variable called node options in order to, well, in this case, load an arbitrary file as if it was a JavaScript file. So we have Node.js being executed, we can control an environmental variable, and we know that via environmental variables we can indicate Node to execute other files. The only problem is that the file needs to be inside the file system. If we have an arbitrary file upload, that will be great. We can just upload a Node.js payload with a reversal to execute it and get back a reversal, and we can just require. But usually you won't be able to find this. You won't be able to find an arbitrary file upload and require. So this guy just thought that, okay, which file could I control inside the victim without needing a file upload? And one of the files you can easily control is proc self environment. Why is this easy? As we have mentioned previously, we can inject via prototype pollution new environmental variables for the new process that is going to be created. So we can actually write in the process environment file that is going to be used in this new process. So the trick is here. Now we have all the pieces for the trick. We know that we have prototype pollution. Later, the for function from the child process library is going to be executed. We can, via prototype pollution, set new environmental variables in the new process being executed. We know that the node options environmental variable is going to be used by Node.js binary as a way to load new stuff in the execution environment. So we can set via the prototype pollution to say, hey, please require load the proc self environment file. And we can control the proc self environment file because we can set arbitrary environmental variables. So we can just set via prototype pollution a variable called, for example, evil, that is going to have, in this case, a log, a console log, that is going to be execute some arbitrary commands. In this case, we are going to be creating the file called pp2rc, simply for showing purposes, for showing that this is going to work. So we can go from prototype pollution to RC just because the software at some point is going to be using child process. This is the way, this is the current way, or the first way we are going to abuse to get from prototype pollution to RC. And actually, let's try this. So let's clear. We are going to be copying this. We copy this. Actually, how was called? Let me check. TMP testing. Okay. So let's start again. We import the child process library. We create an object. We pollute the prototype of this object. This is something, for showing purposes, I'm doing this manually, but later we are going to do a real attack, how a real attack will look like. In this case, I am just testing. I am just polluting the environment of this object we just created. What else do we need to do? We also need to prototype the environmental variable node options, because this is the variable that fork is going to be using. And now let's check out how, if this works, fork should be executing using Node.js the file called afile.js. Actually, this file doesn't even exist, but it shouldn't be needed to exist. I'm a genius. I'm a real genius. So you know that we are attacking proc self environment, and I am attacking in a macOS. Let's get this. A macOS environment, which obviously doesn't have proc self environment. Come on, man. Where is my virtual machine? Ooh, import. Okay, for some reason. Okay, yeah, that's a problem. I don't have any Kali in this machine. That's a real problem. Okay. So this didn't work because macOS doesn't have a proc environment. There is no proc directory. There's no way. Unfortunately, there's no way this is going to work because we were overriding proc self environment, and I don't have that. macOS doesn't use that virtual file system. Anyway, let's do a kind of more advanced attack that I actually created just because of this problem. So we saw the basic way to get RCE. Fortunately, this didn't work because of macOS stuff, but well, you get the idea. We managed to create an environmental variable to require proc self environment, and in proc self environment, our payload will have been written, and because of the require, this will be having executed, and we will have had prototype RCE from prototype pollution just because of this. So let's check how we could do this in a macOS environment. Let me go here. Not working. Are we going? Okay. We are going to use this one. Yeah. Okay. So imagine that you are attacking a macOS server, and obviously the previous and obviously the previous exploit didn't work because you are in macOS. How can you abuse it? Actually, there is another way to do the previous attack, that instead of using proc self environment is going to be using proc self cmd line. This is because in some functions of child process, you won't be able to control the .env attribute that we previously controlled, and then this attack won't work. But fortunately, there are other ways to execute this, and this will be to, instead of attacking .env, attacking RGB0 with our payload, and then to require CMD line. We are doing exactly the same as before. So we, instead of prototype pollution .env, we are prototype polluting .rgb0, and then using the proc self CMD line to execute this arbitrary payload. This is because in the file proc self CMD line, this payload is going to be the first thing written. So if we require it via node options, we are going to be able to execute it. So in a regular way, you will be able either to get RCE through .env or through .rgb0. Unfortunately, we cannot do this because I don't have any virtual machine here, Linux virtual machine, and I'm using MacOS. But just because of that, I was doing some research here, and I was saying like, okay, how can I use this to abuse a macOS machine? It's not pretty common to find a macOS server running a web page, to be honest, but I wanted to find some way to do this. So while checking the internals of child process functions, I saw that some of these functions were using this input attribute. Input attribute is the input that the function is going to be used as input while executing something. So I was thinking like, okay, I can indicate what do I want to execute, prototyping polluting in the prototype, these attributes, and I even can indicate the input I want. The easiest way to execute something with something like this will be, hey, do echo who am I, bus user, like we can control this and we can control this. Unfortunately, this is not going to work in Node.js because internally the code, the library of Node.js is putting .c and something here. And even if you send via the standard input to bus what you want to execute, just because the code is executing what you indicate .c, you cannot remove this and something is always going to appear here. You might, or you cannot control in this case what is appearing here. You won't be able to execute anything via a standard input. So I was thinking, which other binaries may have this -c parameter and are still going to be executing what I sent via standard input. And well, we are going to be relying in the beloved Beam binary, because if we do the exact same example but using Beam instead of bus, we can see that it takes a couple of seconds. It takes a couple of seconds, and where is this thing? Warning, input is not from terminal. Okay, I didn't got this error, and this is weird. Which Beam? Oh, yeah, no, I'm being pretty silly, because obviously that input is not going to be working. Who am I is not going to be working. We need to echo a proper payload for Beam, which is something like this. So if now I check if this file exists, well, we can see that it actually exists. So we managed to get Beam execute arbitrary commands, even if it has this .c something. So we can abuse this in a prototype solution to get RCE from the child process, even in macOS. And now we are going to, well, we are going to execute it, and then we are going to debug it to understand what is happening underneath. So let's open. First of all, I'm going to be removing this file. This does no longer exist. I open a node terminal. Can you? I don't see. You can see this. I'm going to make this bigger. Okay, better. I always forget to make the console bigger. So actually, can I move this? Good enough. So let's prepare the environment. We load child process, we create a random object. We are going to be polluting the parameters cell, RGB0, node options. Node options? Do we need this? Where am I? No, we definitely don't need that. We are going to start it again. This is what we want to do. We import child process, we create an object, we pollute RGB0, cell, and input, and note, this is very important to note, that even if I am saying to execute something, it literally, I'm asking it to execute the command something, because of the prototype pollution that we have performed previously, we are going to be controlling what this is going to be executing. Actually, if you remember the .c something, this is the something we are getting. So obviously we got an error because command something does not exist and it tried to execute it. But if everything worked properly, we should have generated this file. And it is there. Remember that I removed it previously, and now it's created. We can do it again, just to make sure. This no longer works. I execute something after a couple of seconds. this is created. So we managed to control what exec is executing just via prototype pollution, via this pollution. Let's check internally what is happening. So let's create nano test. Yes, we are going to be, oops, let's copy this. And for the moment, I'm not going to be doing the prototype pollution. I'm just going to be executing something. Inspect how breakpoint. Let me check. Okay, yeah. So now we want to do node test.js inspect. Okay. Yeah, that's probably because of this, I guess. Yeah, cool. So let's start debugging that code. We can go now to chrome inspect. Okay. I really hope I can do this bigger. Come on. Yeah, awesome. Let me check. You can see this in Twitch, yeah. Okay, so this is very easy code. We import exception, we execute literally something. We are going to importing this, and then now I'm going to get inside this code. Cool. The first thing you can see is normalize exec args function. It's important to know that, look at this, options, the variable options is undefined. This is what we can attack. We are sending something that is undefined. With a prototype pollution, we could define that thing. Cool. So validate the string. We probably are not interested in this. Validate number of checks. Okay, let's get inside of this. I haven't done this in months, so I will be remembering with you where was the interesting parts. Okay, not that interested. Options. We are now generating the options that is going to be still undefined. Cool. So take a look. Options.cell is undefined. If I go to console and I do options.cell, it's undefined. Take a look to our exploit, well, to our payload or exploit, call it how you want. We are going to be polluting the .cell attribute, so it is not undefined, but it's going to be this. Anyway, let's continue taking a look at what we are going. We will have defined .cell, and the value will be different. In this case, it's just true, just because it wasn't defined. So we continue. Undefined spawn sync. Okay. This is interesting. So now we get inside the function called spawn sync. I think pretty interesting things were happening here. So, maybe I should have got inside here. We can check that later. Let's continue here. So, debug, validate timeout, nothing really relevant. We can modify, nothing really relevant. Obvious, cancel. Note that, hey, options.kill signal is undefined. We could modify this. The way to find other payloads is to just get inside this function and know that we can control the input. So if we get inside here, I don't know, maybe we could find something. Convert to valid signal. In this case, it's looking type string, type number. Yeah, no, in this case, we could prototype this with a string or something. I think I cut the debugging accidentally with a shortcut I didn't know. Well, that's not a problem. This is called debugging. We start again. Inspect. Okay, here we are again. So we get inside here, normalize, we come here. Okay, sanitize kill signal, this is what we were checking, this is undefined, but maybe we can definitely define that. What is this? Actually, let's do something, kill signal. Let's say I have control this and is equals to hello sources. Now we come here, hello, this will be our input, we could control this, we get inside here, get signals name to mapping dot signal is equals to number more. What is going to be this? This is just how I found the other payloads, just going around checking the code that is being executed and knowing what can I control. But yeah, this is not really. Okay, so we could actually control the signal to send to the process, I guess, just by indicating the string, the name of the signal. Okay, don't worry, let's signals, okay. Signal is equals to string. What is this going to be doing? Man, if you're getting boring, you let me know, but debugging is always fun. So, can we do something malicious with signals? So that's a very good question. I don't think so, but I was just trying to go through some example I wouldn't know, so you can see how I will be approaching this. Okay, we are actually moving our signal to uppercase, return signal name. Okay, delete. Okay, we are not deleting the file, we are deleting the attribute file name inside module cache array. If parent is undefined. Yeah, and we die. So yeah, we definitely cannot, I couldn't see anything malicious we could do this time, but this will be the way to find gadgets using prototypolution. Just to go through the library, just to go through what is going to be executed, checking undefined values that you could modify with prototypolution. Again, let's restart. We kill this, we start again, and now we are going to be following the correct path. So we get in here, we don't care about this, we get inside here. We are going to be getting inside this one because normalize spice arguments is interesting. And actually, we can go here, check that, hey, we could modify options.current working directory, we could modify options detach, we could modify options UID, this is things that we can pollute. We could modify options.cell, and actually, if you remember, options.cell is true because previously it was checked if it was undefined. We just saw it a couple of minutes ago, but in this case it's true. But remember that this is because of the other check. We could have polluted previously. We will see that before. At the moment, this is true. Okay, all good. RGB, this is undefined. Let's check again our exploit. RGB, we are polluting this. Again, we are going to be controlling this argument just because it is undefined here. Windows hide, not interesting. If if option cells is true or whatever, some things are going to be happening here. Actually, if it is true, well, we are going to be joining some arguments. We can see, as I told you before, we are going to be using beam instead of bus because the .c arguments is going to be appended. Let's check where is this happening. This is happening here, exactly here. So this is where .c is getting appended. The something I told you is also getting appended to the arguments that are going to be executed, and this is the reason why we cannot use bus or sh to execute arbitrary commands, and we need to use bin, because there is no way we can bypass this appending. So unfortunately, we need to use bin. This was the point where I saw I could not use bus. Again, this is still undefined. We continue. You saw in the previous example I showed you that, hey, you could pollute.env to generate arbitrary environmental variables, and then use proc self environment to execute arbitrary stuff. You can see this at the beginning of the HackTricks page, again, for the people that just joined. This is an example. This is an example, yeah, it was this one, to get from prototype pollution to RCE using proc self environment. We can see proc self environment here. Well, it's because you can prototype pollute the you can pollute this .env attribute right here. This is the place. Again, we are not going to be attacking this part, so we can pass through it. And this is a for loop around environmental variables. So in order to bypass this, I need to go here. Okay, pretty cool. We are not going to be debugging the .env pollution, because I told you before, I'm not in Linux. There is no proc self environment. I cannot abuse it that way. So we are abusing this other way. So what are we going to be abusing? We have seen in which place we are polluting, or where the cell attribute is being used as undefined, and we can pollute it. We have seen where the .rgb0 is undefined, and we can pollute it. And this is the last part of our exploit that was here. We pollute this one. Where are we polluting input? Just right here, options, that input is undefined, so we can pollute this. So we have everything. We can control what is going to be executed, even if it have -c with something, and we can control the input. This is the way we can make macOS execute arbitrary things via prototype pollution. And actually, we don't care about this. And at some point here, in these options stuff, look, in this case, we are going to be executing. Remember this, because this is going to change a lot when we prepare the exploit. bin.sh something. We get inside here. We have spawn actually. Here is where our command was executed. It has already been executed in Node.js. We cannot get more in depth. This is the deepest we can get inside Node.js. Checking JavaScript code, obviously. We could be using a debugging like GDB and continue with the C code or the assembly of Node.js. But with JavaScript, this is the deepest we can get in. So, okay, we have executed something doesn't exist. We haven't done anything in this example. So now is where we are going to be doing it. Let's finish this thing. Nano test Node.js, and here I'm going to be applying our, let's call it exploit, our payload. We are going to be polluting this stuff, and then we are going to be again executing something. We restart this, we get the new one. Cool. We go through the pollution, and we get again inside the exec_syn function. Normalize exec commands. Do we need this now? I don't think so. Not this one. I think we need this one. Let's check. Okay, nothing interesting. Nothing interesting. Ooh. Nothing. Okay, here we are. Okay, but we haven't. Anyway. So we continue. As you know from before, but we skipped that part. Let's try again. I must have skipped something. The moment where options.shell is undefined, and therefore it is our polluted value. Let me try again. Let's see if I can find that moment. We get inside here, and we get directly inside here, and we get, let's get inside all of the functions. Inside here again. This is the moment. Okay, perfect. So if we come here, well, options is option, which is undefined, great. Take a look how options.cell console options.cell in this moment should be undefined, as we have seen at the beginning of this debugging session. But now is user being beam because of our exploit. We pollute this prototype. So great, we have successfully pollute options.cell. If we continue, this is something, this is interesting. We get inside, we don't care about this, Where are the other things we have polluted? Okay, not this, we aren't attacking. So what we can see again, options.cell is user beam. RGB0, again, if you remember previously, this was undefined. Now it has the value that we have defined again, user beam. I think usually it will be enough to prototype pollute cell attribute, but if I remember correctly, it didn't work with beam, so you also needed RGB0 to be called beam for beam to work. I did this like 4 months ago is when I was actually discovering and testing this, so I don't remember how if this is a must or a good have to, but in this case we are polluting both attributes, self and RGB0. So we have pollute both, and take a look, this is interesting. So if you remember previously, the final value of args was, after this we were executing bin sh -c command. So if we continue this flow again, we are going to be getting a different one. Take a look, instead of going to else and say, hey, we are going to be executing bin sh, we are just checking that, hey, in this case, options.cell is not true, is not undefined, it is a real string. So what is going to happen? That instead of using bin sh, we are using our bin binary as we indicated. Great. Again, we cannot bypass this .c command. It is going to be appended, but we don't care because bin is not going to be using this. So great. Same is going to be happening with RGB0. This is not that interesting. And again, we are not exploiting this .env because we are in macOS again. So nothing really relevant here. We finished this function. We have prepared everything to be executing arbitrary stuff from macOS except of the input. So let's go to see how the input affects. If you remember again, previously this was undefined. Now we have polluted in this line, and we are going to be setting the input, the standard input that the bin binary is going to be receiving. We do this, we go finally to chill process here, sponsing, we get inside options. I told you previously, remember what appears here because we are drastically going to change it. In the previous case, here we had user it was dash bin sh dash c dash, this is called dash, well, -c something. In this case, we have bin, and in a standard input, maybe we can see this here, 0. We have actually a buffer with the input we want to pass to bin. So without touching child process, the execing function directly, we managed to completely execute a different stuff from what it was meant to be executed. Let's check again. We are creating this file, so to show you that this is actually working, the file exists, the file now doesn't exist. So we get, it gets executed, it takes a couple of seconds because of the beam stuff. We have already executed this. If I do this, it was generated. So we managed, again, to execute arbitrary things from prototype pollution in macOS. I polluted both .rgb0 and .cell to make sure that it will work. But I am 100% sure that when I was doing test with this, I tried without one of each, and it didn't work. So you highly probably need both. Is that at the end of the poll necessary? That's a very good question. Actually, I don't think it is necessary, but we can check it very, very fast. Nano test. I just sent it because it was free, so why not? But so now if I remove this stuff, if I do node test JS, it takes a couple of seconds again. Actually, it was necessary. Let me try again just to confirm. No, here. So this file doesn't exist. And this exists now. So yeah, actually the new line at the end is necessary. Okay, what else can we do? 15 more minutes. So important to know, this is a way to going from prototype pollution to RCE in macOS. Obviously, this completely depends on the target being using the function exec_sync from child process. What happens if the victim is using exec file? Well, you have here in Hacktricks indicated which trick could work in each scenario. So the use of proc self environment won't work. The trick of using CMD line will work. The stdin won't work, and in Windows this is not working. Why is this Windows thing interesting? Because as most of you might know, exploiting generic things in Windows are usually easier than in Linux, just because you can use this protocol in order to call arbitrary stuff that isn't inside the Windows machine. So remember, previously we had this problem that, okay, man, I can load any file inside the file system and execute it as JavaScript file. But where can I write something I can control? And then we found, oh, you can use proc self environment and create an arbitrary environmental variable. So your payload is going to be written there, and then you can use it. But then there are cases where the proc self environment isn't going to be used, like in macOS, or maybe you can just not pollute environmental variables. Then you can try to use proc self CMD line, but again, you might find places where you cannot do this. In Windows, this is even easier. You just need to indicate, hey, just load this from my machine and execute it, and it will be as easy as that. So if you do this in Windows, this will work, and this is another technique you could use. So again, for each function of child process that allows you to execute code, there are tricks that might work or that might not work, and each trick is indicated in this hack tricks page. You will say like CMD line trick is working, environment trick not working, not working. Let's continue a little bit, 10 more minutes. Okay, if you can see in these indications, you will be able to see this line that says not working after required feeds without options. What does this mean? This means that in previous web versions of Node.js, let's see this better in the commit. In previous versions of Node.js, options, if you remember, we have been polluting options.cell, options.rgb0, options.input, options.env, options.whatever. This was possible because options was an empty regular object. In newer versions, now options is not a regular empty object. It is an object created from kEmpty object, which basically means that options is not going to be inheriting from the parent prototype. So if we do a prototype pollution, options is not going to be getting these new attributes. Or at least I think that was the idea with this commit. Let me show you what this means. If we get this, we do options 1 equals this, options 2 equal this. Oh, not define it. How can I define this? I know how. Okay. Let's do this like this. We are going to get inside. We get inside here, and I guess now we should have a node console with kEmpty object defined. So let me try to. Okay, awesome. We just define it now. Now, if I do something like bool equals this, bool dot admin, bool dot cell equals user bin. If I do options dot one, which is the vulnerable approach, I didn't do it properly. Sorry, guys. A prototype pollution needs to pollute the prototype. That makes sense. If I do options one dot cell, we currently pollute it. It exists. It's bin. Yeah, we managed to do it. If we have options two dot cell, it's still undefined. Again, this is because it's like a null, really null object is created. It's not inheriting from the parent prototype. It's just another one being created. This should prevent this kind of attacks, right? Because as we have seen, like if option was a kEmpty object instead of an empty dict, it's not going to be polluted. It should be preventing this attack. That makes sense, but it's not always happening. So if we come to hack tricks, and we see, for example, where are we? Here. We can see that this trick is not working after require fix, but this is working after fix. And even the one we have been using, this one, is working after the fix. Let's debug why is this still working. It's the best way to understand what is happening. So we do the same, we pollute, because option is going to be defined from kEmpty object. Apparently this shouldn't be working. We have seen previously that this is working, so something is definitely going wrong. Let me find here is where we want to come. Cool. But let me try to find options. This is perfect. So what is option at this point? At this point, option is something empty. Option is something empty because we created these options like this, where we are saying, hey, options, copy options, and options here is something empty. So it's undefined. So we are creating a dictionary that have as initialization undefined stuff. So it's an empty dictionary again. And then we are going to say, okay, now we have defined options, and we have defined options as an empty dictionary. If we continue and we go until here, we can see that options actually isn't undefined. It is defined in the line we just saw previously. So the problem we are finding with this kind of fix for this prototype pollution gadget is that the function, the own function, exec_sync, before using the options object, is defining it as a undefined, as a empty dictionary. So by the time we get to the fix, to this changed code, options is no longer undefined. So this fix only works in a couple of functions, like this one, like spawn, that doesn't define always options before getting to that fix. I hope that make clear sense. Moreover, if instead of doing, so that's not really, no, it's not a fix. Actually, in that fix, I couldn't see any mention saying like, hey, the prototype pollution gadget is no longer working. So I don't think they were meant to end with this type of gadget forever with this fix, but it was definitely a fix with that purpose in mind, because that's the only purpose I could find for modifying that line. So it helps to mitigate, but it definitely doesn't kill the gadget. But moreover, and more important, even if, for example, in a spawn, the options variable is going to be undefined, and therefore is going to be inheriting from empty object, and there our gadget is not going to be working. If the developer, instead of doing spawn something, decided to do this, spawn something with some extra attribute, like, hey, I want you to use this current working directory, the options object is again going to be inheriting from the parent prototype, is going to be getting all the prototype pollution attributes we have attacked previously, and the fix is again no longer going to be a problem for the gadget. So actually this kind of fix, this kind of defense, this kind of extra thing that they have added, it was like mid 2022 when they merged these commits, I think. It's only protecting a couple of functions if the user doesn't define other options themselves as an argument for the function. I hope that makes sense. So yeah, it's a fix, but it's not that isn't that good of a fix. Again, I don't think they were trying to completely mitigate this gadget. I think they were just trying to make it more difficult. Actually, I discovered this fix because I was doing some research and I was doing some testing, and in the Kali Linux I was doing the test. I had Node version 12 without this fix deployed, and in the macOS I had Node version 19 with the fix deployed. So the things that were working for me inside Kali weren't working. Some of the fixes were working in macOS, and it was like, what is happening? Like, Node.js is Node.js. Something may have changed. And then I discovered this KMT object and why it wasn't working, and then I discovered that you can actually bypass it, even defining other options, or in some functions it is not fixing anything. Anyway, I hope that was clear. Some extra stuff that we are going to be checking today, we can do another video if you're interested, but that I wanted to comment before finishing is that, okay, we have seen how to go from prototype pollution to RCE if the code is using child process at some point. What if the code is not using child process? There is no way to go to RCE, or what could we do? And then I saw another write-up and another paper later, where they say that okay, in the first try they say what could happen if child process is not used, but you could control the path to an arbitrary JS file that is going to be included. If you find a JS file that is going to be that have child process, and you can specify an arbitrary internal file that is going to be required, you could actually find a file that, when included, is going to be using child process, and then use the previous exploit, the previous way to exploit this, in order to get arbitrary RCE. And then you can use this very quick and dirty bash script in order to find common JS files that will be executing child process function just because they are being included, they are being imported. So that's pretty interesting. So we can now pass from prototype solution to RCE if we could control some include path inside the file system. What will happen if you cannot control the path, like an attacker controlling a path of a file that is going to be included, that is going to be loaded? That's a CTF. That's not, I don't think that's a real case scenario. It's going to be very, very edge case weird to find. Well, we still have the prototype pollution vulnerability. So what if we could pollute some attributes being executed by the internal required function of Node.js that will allow us to load arbitrary code or arbitrary files instead of what it is meant to be loaded? Kind of what we are doing with child process, like child process is executing something and we are using prototype pollution to execute something completely different. The same, but for require. Require wants to load something, and we are going to be abusing the prototype pollution to load something completely different. Well, the cases will depend if require is using an relative path or an absolute library. And in here, let's check, because I haven't done this in some months and I don't remember this. So if we have an absolute require, like require bytes, and the package.json, every library in JavaScript, in Node, is going to have this file called package.json. If this package doesn't contain a main value you need inside the JSON, you should find a main key with some value. If it doesn't contain it, you could abuse the prototype pollution to pollute that main attribute and make that main attribute indicate a different path that it will be loaded. So again, here I told you, if we can control a path that is going to be required, then you could load something that is going to be using a child process and use the previous technique to abuse that. In this case, we are abusing prototype pollution to pollute something inside a require using an absolute library that is going to change what is going to be loaded. Then we can control what is going to be loaded. It can be something that is executing child process, and then we can do again our previous exploit to get RCE. Very amazing, very amazing. Well, again, these have you need to be importing a package that doesn't contain main. Bytes is an example, but there are other pretty common known libraries that are going to be specifying this main value, so it will depend on each case. And what happens if instead of doing a require of an absolute library, we do a require of a specific library indicating the specific path where it is located? Actually, this is even easier. You can make Node load a completely different path using prototype pollution. And this is because we could pollute the exports attribute with this value, and then the array, we can pollute the the first value of an array. This is 1. Let me check exactly what is this doing. So if we go to node, if we go equals this, if we go to if we do this, 0 is undefined, 1 is undefined. If we do b like this, and we pollute proto 1 equals hello. If we do I got 1 data pollute. Oh no. It's like this. Okay, and now I guess right there. Well, I guess I will need to check internally. Why is this working? Is because put that. Okay, yeah, that's the thing. I put some double columns instead of a dot. So this is something interesting that I have used in other web CTFs, nothing really related, but in prototype pollution you can also change parameters inside arrays if they are not defined. Like in this case, is an empty list, but actually the second item or in the position 1 is going to be polluted by our attack. So just to finish, if we indicate a relative path for a require, after a prototype pollution, an attacker could abuse it to modify this couple of arguments and make it load an arbitrary path. Again, then we can search for common files in file systems that are we going to be executing child process when loaded, and then we can just set the other prototype pollution to abuse one of these cases in order to execute it and get arbitrary RCE. And that's all. Actually, in a couple of weeks ago, YouTube is like this. Tricks live. This is going to work. Yeah. We solved some CTFs, and I solved one. And Ignacio, Dirty Bird videos. That was called Dirty Bird. Okay. That was called Dirty Bird 2, where it was a CTF where you actually needed to abuse a prototype pollution to pre-bask with the isadmin trick and then to get RCE. Moreover, none of the techniques, none of the exploits I have showed you here will work in this vulnerability because I made some changes for them to not work. So you will need to find another way by debugging what we have just done, by debugging the child process code in order to find another way to get RCE. There are other ways. There are edge cases where polluting env or RGB0 or these ones, you cannot abuse them, but then you can pollute other things to get RCE. So if you are interested in a real CTF using this prototype pollution to get RCE, feel free to take out a look to this video. So I'm going to finalize this video. I'm going to give a couple of seconds to allow people to ask questions. This video is going to be published in Twitch for the following 14 days, something like this. And this week or next week, I will also be publishing this in YouTube. We have seen how to go from prototype pollution to RCE. First of all, abusing child process. Second of all, abusing other stuff like requires that will allow us to get to the child process point, and abusing that, the previous thing, we will be able to get